Thank you. All right, it is now time by the clock on my laptop, so let's get going. We have a fairly full agenda. Welcome. Please remember the note well. These are your responsibilities if you're going to contribute. If you can't fulfill these responsibilities, please don't contribute. Remember the code of conduct. Please treat each other with respect. It's okay to attack an idea. It's not okay to attack a person with the idea. Meeting tips. If you're here in person, please use the online tool. We will be using it for getting in line for the microphones. It also automatically does the blue sheets. If you're remote, please don't use your audio or video unless you're in the mic line and the one at the front. That way, the bandwidth works out better for everyone, and headsets usually help. So this is the agenda we posted. As I said, it's long, 11 items here, 10 of which are about presentations. Any agenda bashes?
Job Snyder's, Fastly. In the most respectful way, I want to express a little bit of disappointment with how this agenda came to be and encourage the chairs to do better at the next meeting by, for instance, issuing a call for talks. Thank you.
Yes, I think all three of us acknowledge that we need to do better going into the next one, and we have tried to put some processes amongst us in place to make sure we do hold us accountable to actually achieving that next time. Thank you. All right, let's get started with the first draft. Tim.
That doesn't actually do that.
Yeah, it doesn't.
Say next slide if you will.
Yep.
Yeah. Okay. Oh, hi everyone. So I wanted to talk about the a document about a best current practices for running a publication server. Next slide, please. If you watch the mailing list, you might have noticed that it's now adopted. Yay. Adoption call started a while ago, actually. Some comments were received. Recently adopted, a new version has been uploaded just now. I assume everybody got a notification of that after Chris said, please do. There is some stuff in our edit buffer coming shortly, but I'll get to that in a moment. Next slide. First, I want to very briefly do a recap of what this is about. The scope of this document is really about running the publication server. If you, without going into all the gory details, certification authorities in the RPKI can use a publication server as a separate logical thing, let's say. It could be integrated, but logically it's a separate function using the RFC 8181 protocol for publication. Then the publication server is responsible for publishing the actual content sent to it by CAs and making it available both over RDP and rsync, which is then retrieved by relying parties. So the highlights of this document, we talk a bit about 8181, mainly to point out that there's a different impact in case CA cannot update its content as opposed to relying parties not being able to retrieve content. But I think improvements to the actual protocol, and I'll get back to that in a moment as well, are most likely out of scope for this document because we're dealing here with what we can do currently. Next slide, please. RDP, so key findings, there's more in the document, I encourage you to read it. But one thing that is very important is that you need to ensure somehow, and we go into details how, that the notification file is only made available once the deltas and snapshots files can also be retrieved. In particular, there is a bad feedback loop. So RDP in general actually uses, in ideal circumstances, uses less data than rsync transfers, mainly because of compression over HTTP. But there's a very bad feedback loop, because if relying parties cannot retrieve certain delta files, then they're supposed to get the snapshot file. And if they all start getting snapshot files, then, it gets worse. So advice is provision for this, or use a CDN if you can. Next slide, because 10 minutes. Quick highlights for rsync. rsync has other challenges. In particular, if you want to make a consistent set of data available to relying parties, there's a trick you need to do, or well, the best trick that we know of is to have a symlink to a directory that contains all the current information and use that for your rsync module. Some other things like setting predictable timestamps to avoid retrieving extra files. Yeah, I don't want to get into all of this because of the time. But, just giving you the overview. Next slide, please. Oh yeah, one more thing. We talk about this briefly in the document as well. As you may know, the RARs provide hosted RPKI services with publication for their members, and some NARs do as well. And by far, most people out there use this, but you can also use your own delegated RPKI CA, and you can then choose to use your own publication server as well. And there are definitely use cases where you need to do that currently, especially if you want to delegate further down. But in general, it's probably recommended to use one of the publication servers provided by the RARs or NARs, if you can. Now, rushing forward, what is in the pipeline for the next revision? Well, there's some nits, they're not that interesting, I think, mainly typos and clarifications. One thing that's still missing is what to do in case your publication server, as your operator publication server, it goes down completely and you need to do a restore from backup. There are some nasty corner cases there that I actually also need to discuss with my co-authors a bit more before providing new text. But yeah, obviously really try to avoid this, but yeah, okay, reality might be that you cannot. The problems here are, there are a couple. So relying parties may get confused if the RDP serial regresses or if the hashes change. Yeah, you can solve this by doing an RDP reset when you do a restore, but perhaps more painfully, the content of certification authorities may also have regressed, and they may think that they have a manifest that's perfectly valid for another 24 hours, whereas the one that's, that has been restored is only valid for 5 more minutes or less. And there's no way that the server can tell the CA to come and republish. So this needs some thought and some more discussion, I think. Like I said, likely out of scope are things that we can do in the RFC 8181 protocol to improve this. It would be great to look into that, but I don't think we can do that in the context of the best current practice document. So parking that for now. And next slide, please. What I want to drive at is I'd like to publish that as your one version of the document, discuss, and then probably go fairly quickly towards the last call. If you have thoughts on the publication server restore in particular, then I'd be very happy to hear them. And yeah, any other questions, comments?
Ben?
So on your sorry, Ben Madison from Work Online. Your previous slide said quotas and quota enforcement were out of scope.
Yep.
Your previous slide said that quotas were considered out of scope from your perspective. That
Yeah,
seems to me a
well-
fairly obvious topic for this kind of thing. Why is the plan not to talk about that?
What I meant to, my intent with this slide was to indicate that there's many things that we could improve on. Like we could think about quota, we could think about servers checking that the content actually makes sense, parses, or is even valid. And I think those are very useful discussions to have. But if you would enforce that currently, you don't. If you enforce that currently, you don't really have any good way in the protocol to communicate any errors. And there's no way really for CAs to do anything with that information because they just get a general error.
Yeah.
And that's why I don't think we're ready to go there.
So probably best left for an update to 8181.
I think so.
Just one other brief comment about the guidance for publishing in parent. I think that guidance for publication server operators as to why that's a good thing for them to do is certainly something that this should contain. I would steer clear of guidance to issuers about why they should do so, simply because I don't feel like this is a document that's likely to get read by this audience. And so that guidance, I think, will largely go unnoticed and may, as a result, not show up in a better place down the line. I agree that the guidance is good. I just don't think this is where it should be.
Well, yeah, I think it should also be in other places, but I don't think it hurts to include it here as well.
Hi, Niklas Vogel from Athene. I was wondering about the recommendation you made about people publishing at the publication points of the IRRs. So, like, is the purpose of the RPKI to have a more centralized system, or would it be desirable in the future to also have like more people setting up their own publication points?
So the CA functions and publication functions are separated for a reason. So even if you have centralized repositories, the keys can still be delegated, and
Right.
that's ultimately where the security is. Under the current standards, you can only publish in one place. And we see a lot of issues with delegated repositories not being available. So in that sense, I think it's better to do decentralized. Maybe in future we can think of more things, but yeah, that's a bit out of scope for now.
Right.
Like mirroring, or just thinking out loud. But yeah, I don't think there's a security issue with publishing at the RER. I mean, you still have the key, so.
Job Snijders, Fastly. I think the key is that we want publication points to be monitored and operated in a reliable fashion. And practice now has shown that many delegated publication points are not operated in a well manner. And this wastes cycles on the RP side.
Yeah.
So waiting for the timeouts. So I think the fewer publication points this ecosystem has, the better from an efficiency perspective. And where to strike that balance, like I run my own publication point because I need to do RPKI development, but I would recommend everyone else not to do that. I think including this guidance in the BCP is good.
Okay, thank you.
Thank you.
Hello, everyone. Please
Hello.
give me a thumbs up if you can hear me.
Yes, we can hear you.
Great. So, my name is Alexander Azimov. I work for Yango, and it's been a while since I last participated in a SIDROPS meeting, but it's good to be back. Today, I'm going to talk about ASP documents. Next slide, please.
I passed you slide control.
I see. Okay, great. Yeah, wow, it works. So there are three documents that are bound together. The profile document that describes the ASP object format, the ASP verification document that outline procedures for checking IcePath, and the RTR-related document that defines ASPA PDU. In this presentation, I will discuss latest updates to all three documents, as well as open questions that remain. Let's start with the profile document. In the latest update, a reasonable limit was added to the number of provider IS that one customer IS may push into the system. Some of you may remember an interesting experiment when people from academia decided to check whether very long IS paths would be properly processed by all routers in the world. The result of this experiment caused numerous BGP session flaps across the globe. The precaution should help when people from academia and their experiments will return. This change has not affected the profile specification, and I believe ASPA object is quite stable now. Now let's jump to the verification document. It has undergone major restructuring and rewriting, and I won't have time to go over all its changes. I hope you've already checked it out, and I focus on the most significant update, the definition of invalid and unknown paths. A key observation was made a few years ago. Each valid ICE path may have an up ramp followed by a down ramp. If the sum of lengths of the up ramp and down ramp is less than ICE path length, the path is invalid. Invalid means that ICE path has been leaked or malformed. The great thing about ASPA is that it can be used to measure the length of up and down ramps. Let's start with an obvious example. Here we have 6 autonomous systems, each of which has registered ASPA record. In this case, we can measure the exact length of the up ramp and the down ramp, and the sum is equal to autonomous system length, so the path is valid. Unfortunately, this ideal scenario differs from the real adoption process, where only a fraction of autonomous systems will participate. Now, let's say that autonomous system 3 and autonomous system 5 have not registered ASPA records. Therefore, we can measure the length of the up ramp to be between 3 and 4, and the length of down ramp to be between 2 and 3. The outcome verification procedure will be unknown because we don't have enough information. This leads us to a generalized definition of the ICE path check using an ASPA. If the sum of maximum of up ramp and down ramp length is less than ICE path length, then it is invalid. If the sum of minimum of up ramp and down ramp length is less than ICE path length, it is unknown. Otherwise, it is valid. This mathematical definition clearly corresponds with our original definition of invalid ICE path. The use of min-max length variables has greatly simplified verification procedure definitions. Overall, the feedback has been positive. Now, let's discuss the most difficult question. The address family flag has a long history in the ASPA documents. It was originally a mandatory part of the ASPA object. There was an attempt to make it optional, which failed due to complications that were required at the validating software. About a year, there was a discussion if we should drop it for good. Both options had valid reasons. On one hand, there is still difference between IPv6 and IPv4 customer to provider datasets. On another hand, we could simplify both registration process, narrowing the field for possible mistakes, and also simplify processing on the router software. To make my mind, I decided to extend the modeling of autonomous system connectivity with a ground study. I asked fellow operators, asked on mailing lists, and even sent half-automated emails to ISPs. The one question I asked was, according to my model, you have a provider in IPv4 and no connectivity in IPv6. Can you explain me why? Responses can be clustered into two types: mistakes in routing policy configuration or lack of visibility in my model. With this in mind, take into account the fact that simplification usually boosts adoption rates, we finally reach a broader consensus that address family flag should be removed. The latest update to the RTR protocol follows this decision. Therefore, all three documents are now synchronized with their interpretation of ASPA objects. The publication of ASPA verification and RTR documents has raised some questions and discussions in the mailing list. I want to cover two comments in these slides. The first comment came from Randy about the abstract that was added to the ASPA verification document. There I stated that with a growing volume of traffic, more ISPs would have proper monitoring for both V4 and V6 sessions with their customers to ensure that they are in established state. However, Randy also pointed out that this statement may be speculative, so we just removed it. The second discussion took place in thread related to the RTR document update. A question was raised about whether we need the provider IS count field. If not, whether we could move the flags field to the first 32-bit area. I felt that there was no consensus on this issue in the thread, so I thought it would be helpful to hear the points of view of Randy or Rob or early implementers who might have joined us today. By the way, Randy, if you can turn on your mic, it will be great. Or we can just skip it and move it to the questions.
Go ahead, Nan.
See chat.
Okay. So this is my last slide. SPA has been around this working group for about 6 years. It has been significantly improved since its early versions, becoming what I feel a solid specification. However, any technology has a window of opportunity, and it won't last forever. For SPA, it's right now. I hope we can solve together last minor issues and progress these through 3 working group items to our ASG. Please, any questions and comments?
Okay. Nankang from Huawei Technology. Thanks for updating the drafts. I think it's ready to move on. But my question is about the second open question, the RTR ASPA PDU. I think we do not need to change the position of flex field because in the IPv6 prefix PDU and IPv4 prefix PDU, the flags are also in the position after the length field. So we can keep the consistent design as the existing PDUs. We do not need to move the flags field in the ASPA PDU in different places. Thanks.
Thank you for your comment. Great. I'm feeling great. So the discussion was kick-started.
Rüdiger Volk. Hi, Alexander. I can tell that, yes, the quite serious rewrite you did has improved the verification document. After such a major rewrite, it is expected that a little bit of more wordsmithing and fixing may be needed. If I read your slide with the red removed, well, okay, that's a part. Actually, I think we need to go a little bit through the details. The security consideration section, for example, quite certainly looks much better now, but I don't think everything that's there belongs under security considerations, and I'm not sure that everything that would be expected in the security considerations is in there. I'm likely to provide quite a number of written comments, though that's going to wait until the second half of August.
Okay, so we will have to postpone slightly progress into ISG, but okay, it's a joke. Rüdiger, thank you. We will be waiting for your comments.
Job Snijders, Fastly. I think we're almost ready to move on. Right now, our focus should be the RTR document. I think there are about 5 topics that are worthwhile discussing in the group via email. In particular, ordering of information inside the PDUs, because I think this is our last shot at making the RTR protocol as good as we can, because after publishing this, we'll be stuck with it for a number of years. Randy Bush, Rob Austin, if you need help or would like textual contributions, I'm happy to spend some cycles if there's a shortage of time on your side. But yeah, we're almost there. And ideally, working group last call starts with a number of finished or products that operators can use to set up the entire pipeline from signing to validating into pumping it into multiple BGP implementations, so they can inspect the entire pipeline before supporting progression to IESG.
I think I don't have any additional comments to what Job said.
Tim Wijsels, Right NCC. Just a small comment. First of all, thank you for presenting about this, and maybe similar to Job, my feeling is that we're close, but there are some open issues that need to resolve. Please resolve them. Please keep that momentum going. We have an implementation in our test environment to produce ASPA objects. We would very much like to enable this in production, but we cannot do so until things are resolved. So I would say, please keep the momentum going. Thank you.
We will try our best. Thank you.
Okay, thank you.
I'm always a bit too short for this. Good afternoon, everyone. I'm Sophia. I'm the NRO RPKI Program Manager. In March in Brisbane, I did a similar presentation for the IEPG, and I'm really grateful for this time slot to present to a bit of a more appropriate audience. Next slide, please. And to start with, because I'm a new participant to the working group, although I have attended a few IETFs, I haven't been very active in this working group before. So I wanted to understand a bit more. So just quickly, I wanted to understand about your role in the internet routing system. So who of you are operator of content networks and of transit networks? And you may be playing more than one role. Developer of tools, researchers. Awesome. And other? Is there anyone who, okay, cool. I would love to hear about those, but not right now. But thanks for that. Next slide, please. So what I would like you to get from this presentation today, first, I would like to raise awareness about this new program. I started as a program manager in January, and it's relatively new. So I would like everyone to know a bit more about the program. But also, I hope I will be able to spark enough interest for someone to reach out to me and give me some input. And throughout the presentation, I will be mentioning some specific things that I think is really important for us to get input from the community. But also, I hope to spark some curiosity so that you want to learn more about the program. And I will provide means for you guys to do that. Next slide, please. Just a little bit, and as I mentioned, because I'm a new participant and I'm sure a lot of you don't know me, quickly I wanted to share, I studied telematics engineering, both my undergrad and my master's, but then at APNIC I became a product manager and later an ontological coach. So I've been a bit derailed from the technical path. So just coming back to the technical world very recently. I have attended a few IETF meetings, but I have not actively participated in any working group. So I'm very new and inexperienced in terms of how working groups work. So that's another thing that I would really rely on you guys. And finally, in terms of my experience in the internet world, I joined LACNIC first in 2010, and then I moved on to do my master's. And after my master's, I joined APNIC. And now since January, I'm working for the NRO. And for those of you who may not know what the NRO is, it's the number resource organization that brings together the 5 regional internet registries. So APNIC for Asia Pacific, but AFRINIC in Africa, ARIN in North America, LACNIC, and the RIPE NCC, with the mission of actively contributing to an open, stable, and secure internet through different initiatives, both in the space of technical coordination, but also in the space of governance. Next slide, please. And now I would like to introduce the NRO RPKI program. Next slide. Back in 2022, the NRO went through a strategic review process, and the NRO Executive Council, which is the 5 CEOs of the 5 RIRs, agreed to work towards providing a robust, coordinated, and secure RPKI service. So in January this year, as I mentioned, I started my role as the NRO RPKI program manager. This program was actually created last year, maybe end of 2022, and some conversations started. A steering group was formed. And this year, in the first few months of the year, we focused on agreeing, okay, what is the purpose of the program and what are the most specific outcomes that we can achieve? So as a purpose, we are aiming towards providing a more consistent and uniformly secure, resilient, and reliable RPKI service. And one of our hypotheses is that we should be able to benefit those network operators that interact with multiple RIRs, so that they have, if they have presence in multiple regions, and maybe experiencing the inconsistencies or differences among RIRs as maybe a barrier for RPKI adoption. So we hope we will be able to benefit those, among other benefits of the program. Next slide, please. And why we believe this program is important. The RIRs have been collaborating and coordinating for quite a while in different spaces, but the RPKI program creates a space for more structured coordination and collaboration. And we are aware of some diversity and the differences, as I was saying, among the RIRs. And just as an example, I included a screenshot of a manners document that summarizes requirements and security standards for operators of RPKI services, for example, the RIRs. And in the annex has that table, which is a bit out of date, so some things may have changed, but it's just an example of how, for different aspects, some RIRs may be aligned or compliant and some may not. And that those differences are the ones, or some of the ones we're trying to understand how they may be impacting RPKI adoption. Next slide, please. We do acknowledge that the differences may be in different aspects of the RPKI system, right? So it may be that some RIRs offer some services that some others don't, or that they offer services in different ways. There's also differences in the user experience, for example, for those that create ROAS using the graphic interface. And I have a slide to show that. You may see that the portals look quite different. But then for the RIRs that offer APIs, the endpoints may be different. But also at a lower technical level, there may be differences in terms of design decisions or the actual implementations. Next slide, please. So yeah, this is the example of the user interface. So the user experience through the 5 portals may be a bit different. The fields that are required may be different. The vocabulary used may be slightly different. Even the information offered so that network operators can create their ROAS based on BGP information may be different. In some cases it's available, in some cases it's not. Next slide, please. So what we are asking ourselves is whether those differences are hindering RPKI adoption. Next slide. As I mentioned, the purpose of the program is to provide more consistent, excuse me, and uniformly secure, resilient, and reliable RPKI service. But as I mentioned earlier this year, we were having conversations with the steering group about what are those more specific outcomes that we may start working towards. And the first thing we agreed on focusing on is understanding what would a single global RPKI system look like. So although the title of my presentation talks about an RPKI service in singular, as I mentioned, in practice, each RIR has their own implementation. So we want to really understand first where we are at right now, but also what are the community expectations in terms of that single global RPKI system. Then there's a couple of objectives that are about some specific aspects of the system, like the second objective is around understanding better and improving the transparency about the robustness of the system, and the third one around security, so enhancing the security consistency of the RPKI system across the different RIRs. And the final one, and this is where a lot of my work happens, is about keeping the community informed and engaged throughout the program. For example, this presentation, and also if there's any concerns that we can address them in a coordinated way. We do acknowledge that each RIR has the regional communities, and there's conversations happening there, and there's input, regional input being dealt with at each RIR, but in the space of RPKI, we would be able to respond in a more coordinated way. Next slide, please. As I mentioned, a lot of focus has been put on that first outcome around really understanding what a single global RPKI system would look like. We started by documenting the different services and features and what's the current state of things in terms of what RIRs offer them or not, and how, so that we can identify and prioritize gaps. We've been working also on a problem statement around the current trust anchor configuration, summarizing history since 2005. And we are doing some preparation for user research in the next couple of months. So if any of you would like to participate, please, when we send that invite out there, it would be great to have lots of participants so that we have good representation. The idea is to validate whether those differences we've talked about are hindering RPKI adoption, and also what are the ones with like highest impact so that we can prioritize work on those. Next slide, please. When I say we, the program team, I mentioned already the Executive Council, that is the CEOs of the 5 RIRs. The RPKI steering group is RPKI experts from the 5 RIRs, myself, but also RPKI subject matter experts from the RIRs. Next slide, please. Just conscious that I'm running out of time, so my last couple of slides, next slide. Next slide, please. If you do want to know more about the program, there is a webpage under the NRO website, and also a couple of blog articles that have been published through the 5 RIR blogs. And next slide, please. If you do want to reach out, we would like to get input from the community, as I mentioned, in particular, if there's any big barriers or obstacles that you think that in terms of RPKI adoption that we could solve through better coordination and collaboration among RIRs. But in general, if you have any ideas or like of initiatives that we should consider, please reach out to that email address. And that's it. Thanks. Thanks for your attention.
You
Randy?
have some questions. Randy?
How do you measure RPKI adoption? There's not just how much is published, there's how much is implemented in routers, in what parts of the internet.
Agreed. Is there a question there, Randy?
Yes, how are you going to measure it? I'm a measurement guy.
How we are measuring? Oh, I'm not personally measuring everything. I'm trying to use everything that is already out there. So I'm happy to share some URLs, but I'm sure you're aware of all the projects that measure adoption of RPKI, adoption of route origin validation.
Ben?
Hi, Ben Madison, Work Online again. Thanks for that. I think this is really, really useful. I think there's been there's been informal coordination, but I think having an actual, an actual forum for that to happen and an actual program to guide that is really important. One comment I'd make, which there's probably nothing you can do with this immediately, but I think it's important to acknowledge that there's going to be quite a disconnect in terms of the kind of subject matter that gets wide interest and attention from the member bases of RIRs. That's going to be kind of like user experience stuff. It's going to be API definitions. It's going to be web portals that look nice. And I think that there's also another category of thing which is going to be much less widely interesting for people, but I think actually more important and more and more the kind of stuff that you guys are uniquely placed to actually work on. And the thing that springs to mind there is taking a look at the current trust anchor layout. Like we all know it's really, really fragile and it's there for a reason, but I think taking a good hard look at that a few years down the line would be really valuable work.
Yeah. Thanks so much for your comment, and that's why I'm inviting everyone to participate when the time comes. We will be sending invites to the relevant mailing lists, and we are hoping to get a very good distribution of participants so that we can have that representation. So I will send you an email directly so that you can provide your input. Thanks for that.
Okay,
Thanks,
thank
everyone.
you. Oops.
This is not the slide deck you're looking for.
Yeah.
I'm Job Snyders. I work for Fastly. I have glasses now, so I can actually see my slides. It's fantastic. CRL numbers, apparently is the first one. Next slide, please. In recent months, a group of German researchers pointed out discrepancies amongst multiple relying party implementations about how the CRL number extension inside CRL objects is handled or not handled. Tom Harrison from APNIC expressed concern about CRL numbers maxing out, reaching the highest possible value, which is 20 bytes minus 1 bit. And we have an RFC that mandates that CRL number extensions must be present in RPKI CRLs, which all prompted me to investigate what the heck are these CRL number extensions even for in our ecosystem. Next slide, please. Quick recap, what a CRL looks like. CRL is a digitally signed object that contains, amongst other things, an authority key identifier, the issuer of the CRL, when it was produced, when you can expect the next update, and a list of revoked certificate serials. And it contains a field called the serial number. And this is done in the serial number extension. Next slide, please. Serial number is a non-critical extension, and the original RFC that specified X509 version 2 CRLs specifies that it is a monotonically increasing sequence number, and this monotonically increasing sequence number can be used to figure out which CRL is the latest one, which is the one that I should be using. So the serial number in other PKIs can be used to choose amongst multiple simultaneously valid CRLs which one should the relying party use. Next slide, please. We have seen this movie before. Next slide. In manifests, we have the manifest number, which is a monotonically increasing value that we use to decide which version of the manifest is the one that we as relying parties should be using. Next slide, please. I argue that serial numbers in context of the RPKI serve no purpose. Because a well-formed manifest contains exactly one entry for the CRL, and that one entry contains a collision-resistant digest that addresses the content of the CRL the CA intended the RP to use. And additionally, the serial distribution point in the CA resource certificate references the CRL by name. And as manifest numbers monotonically increase, this helps us detect replays, not just of the manifest itself, but also of the content listed on the manifest. So together, all of this guarantees that relying parties can unambiguously decide which CRL they have to use if there are multiple available. So in other words, I would argue, because we have manifests, the function of CRL numbers as originally thought up by RFC 5280 is fully subsumed and they serve no purpose. Next slide, please. So there's a number of cases that are resolved if we ignore the contents of the serial number extension as relying parties. Case one is a very simple one. For instance, if the serial number maxes out with manifests, if the number maxes out, we identify this working group that we need a solution, and Tom Harrison has been driving a solution that we rename the manifest file. In the case of CRL numbers maxing out, I argue that the problem of them maxing out simply disappears if we ignore the thing. Next one. And there's a far more complicated case, but if you do a fetch and you get a partial repository state, and this can happen if a new CRL object appears in RDP delta 1, and the manifest and other associated products appear in delta 2. At that point, the RP has the old manifest, but from the RP perspective, it's the latest manifest, and two CRLs, the old one and the new one. The new one revokes the old manifest. But the manifest RC says that if you have a partial fetch or a failed fetch, you have to use locally cached objects, which would mean that you do not use the new CRL, even though it has a higher number. In this type of situation, the CRL number has no constructive purpose because we prefer the way manifest filled fetches are handled, and trying to use the CRL number as a means to discover which is the CRL the CA intended us to use becomes very complicated. So I would argue that the 5280 purpose stated for CRL numbers is somewhat incompatible with how we do things in the RPKI. So again, relying parties simply ignoring the CRL number extension resolves this case. Next slide, please. So in RPKI client, the validator shipping in OpenBSD, we have now arrived at this implementation. We check that the CRL number extension is present. We check that it's marked non-critical, and that's it. We do not look at the contents, and we don't do syntax checking on the contents. I would advise other RP implementers to follow a similar pattern, and this is also the pattern described in the draft proposal. Next slide, please. So next steps. I would encourage RP implementers to double check what they are currently doing with the CRL number, if anything. Please review this draft. It's fairly short. I think it articulates the arguments in a concise way. And finally, dear chairs, I would ask you to consider starting a call for working group adoption so we can jointly work on this. Comments, questions?
We have one in the queue.
QMISL, MPI Inf. Why are you checking that the CRL is there at all? I presume there's a good reason for that, but could we just, like, I get why we can't just delete it, because some RPs which don't follow this will go, well, that's not valid, but why do we even need to check that the number is there?
I suspect it is for hysterical reasons or historical reasons. So at the time the RPKI framework was designed, a conscious choice was made to recycle existing components like X509. And it was very reasonable to say we want to use the X509 version 2 CRL profile as is, because a lot of tooling works that way. So if you remove the CRL number extension, it no longer complies with the X509 version 2 CRL profile. So I think it's a reasonable compromise to say CA issuers must include the field, because that's the profile we picked, and RPs should ignore the contents of the field because we have no purpose for it.
Wouldn't it maybe be nicer to say that RPs should just ignore it entirely, and then maybe in future we can come back and say CAs just shouldn't include this?
That's a very reasonable point to bring to the working group, and we should have that conversation.
Yes.
I am mainly here today to argue that the contents of serial numbers have no purpose, and maybe if we arrive at a consensus to somehow get rid of the field or not check it, that's an advanced step.
Bob Beck, necromancing old standards fan. Are we absolutely certain we're also not having implementations doing stuff like sneaking CRLs through AIA or other such fetching mechanisms because they've...
Can you speak up a little bit?
Are we certain we do not need to give advice to avoid fetching CRLs via other mechanisms where this would matter, such as AIA or any of the other ways you can sneak into a certificate to ask for one?
As far as I know, all implementations use the manifest as the discovery starting point. And for debugging purposes, some implementations can follow AIAs and associated CRLDPs, but that is not the general case as it is used in the production environment. So I think there is no concern there.
Mike, please.
Ben.
Ben Madison again. So you correctly identified the one point of disagreement amongst the authors.
Please speak into the mic.
Sorry, I'm doing my best. I'm right here. You correctly identified the one point in which the authors disagree. I come down on the side of ignore the extension altogether. My co-authors come down on the side of check that it's there per the profile, but then don't process its contents. I think it amounts to the same thing in terms of correctness. I'm not sure that I feel qualified to dictate what the answer should be. I think that should be a question post-adoption. Bob, if I understood your question correctly, Bob, concentrate. Bob, you're still there. If I understood your question correctly, that scenario would still rely on additionally following the CRLDP, yeah? So that's the I forget which document, but it is mandated that the CRLDP must refer to the same name as that listed in the manifest. So if you're correctly following that step, then that kind of circuitous backdoor should still be cut off in the existing standards. But I don't know that's true in practice, but it's true in the documents.
We should definitely discuss this in the hallway. Next slide. Next slide, please. The next draft is tie-breaking trust anchor certificates. Relying parties have a trust anchor locator that contains a public key and one or more URLs. They fetch the object from the URL, verify that the public key in the TAL is the same one signed over in the trust anchor certificate, and whether the self-signage is correct. You can imagine that as a relying party, you may still have a previously fetched copy of the TA certificate around in case the fetch fails, you encounter some HTTP error or something else. But in case the fetch goes well, you have a choice. The using the TA certificate that came from the network or using the TA certificate that came from disk. Next slide. Why this is relevant, there still are super old trust anchor certificates that are still valid, and they date back to 2014, 2015, and they contain internet number resource listings as subordinate resources that are woefully out of date. So if these old certificates that are still valid and cryptographically valid are reintroduced into the ecosystem, perhaps by some network caching element like a CDN or a provisioning mistake, it would potentially wipe out significant parts of the PKI structure. I've made an analysis of the availability of older certificates. You can click the URL. Next slide, please. So the previous slide sort of demonstrates that it would be nice if stuff from 10 years ago cannot bite us today. And for that, we need to move towards short-lived trust anchor certificates. And with short-lived, I mean something along the lines of a year. And practically, trust anchor operators critically depend on a degree of agility because they must be able, in a timely fashion, to update the subordinate INR listings, the subject information access, for instance, if we come up with RDP version 2 or deprecate rsync, and they may want to change the URL of the certification and practice statements. So it is entirely unreasonable to imagine that for the next 50 or 100 years, these aspects would not change. Next slide, please. Then on the relying party side, it is beneficial if we document a standardized means how to choose between multiple valid TA certificates and how to pick a TA certificate amongst multiple valid TA certificates is a little bit tricky because we cannot rely on the certificate serial. That one is not monotonically increasing. None of the X509 V3 extensions provide useful clues what the better certificate is. But we do have the not before and not after date as an indicator of recency. And one could also argue that the source of the object, the network or the disk that contains the previously cached version of the object could be interpreted as a sign of recency. Next slide. So with manifest, this was super easy, right? You just look at the manifest number. One slide back, please.
One more.
One back, please. Yep. So with manifest, this was super easy. You look at the manifest number, you take the highest one, you're done. What we implemented in OpenBSD RPKI clients is that we prefer the TA certificate that has the more recent not before. If the not before is the same for the object fetched from the network and the object cached on disk, we look at the not after and we choose the certificate that has the soonest not after. And if the validity period between the two certificates is equal, we pick the one that came from the network. Next slide, please. The justification is we assume there is no or minimal backdating. So the not before is very likely to be close to the actual moment of issuance. And using this in the tie-breaking scheme will encourage TA operators to not recycle not before values. Always keep moving your not before forward if you do new issuances. Overly long validity periods are unreasonable from the perspective that we can formulate arguments that there is a high degree of uncertainty what happens 50 years from now, and therefore issuing certificates in the range of 50 to 100 years doesn't make a lot of sense. And therefore, we prefer certificates with shorter validity periods. And then finally, an object stored in the local validated cache on disk originated from a previous fetch, which is earlier in time, and an object fetched from the network is therefore can be considered more recent than the one that we got some time ago. The tie-breaking steps are in order of progressive unlikeliness. So step 3 is within the RER ecosystem very, very unlikely to be hit. And step 2 can only be hit if the not before is recycled across multiple issuances. Next slide, please. So my question to the group is, please take a look at the proposed tie-breaking scheme. Please consider implementing a notion of a local validated cache for TA certificates, so that if the remote point presents you something that is either cryptographically invalid or an HTTP 404 error, that you fall back to something you obtained before. We need to figure out if we adopt this concept, whether to do a BIS document on the trust anchor locator RC, or maybe just patch the section of text that deals with how to make this choice. And we can either adopt this work as working group, or go for an independent submission and just say this is what one specific implementation did, and not make it a working group document. So I would love your feedback on this, perhaps on the mailing list, because I'm already over time. My apologies. Yeah, and this is it. Thank you.
So please, let's hear some discussion on the mailing list about that.
Hello, can you hear me? Hello?
Yes, I'm going to
Oh.
give you control of the slides.
Okay, thank you. Hello, everyone. I'm Yu Fu from China Unicom. Today I want to discuss whether to synchronize the RPKI data that is not required by network. We have introduced that in the, I think in future, IPv6 only network is only interested in the IPv6 related BGP validation. So we have introduced in the Australia meeting that in China, there are a new China education and research network named FITI, and the construction will be an IPv6 only network. And also China Unicom is fastly upgrade our network for the IPv6, and we are considering to deploy IPv6 only network in the future. So we have do some tests in our test bed that when a network receives unnecessary RPKI data, maybe there's some disadvantages. So with the first one is waste of the storage on routers. So we do test on the our test bed, but that if we only use the IPv6 only data, we can save 67% storage. And the second one is induce some unnecessary transmission overhead. And the third one, we think that this is the not energy efficient. So we want to discussion that at present there are RPKI data types in the RTR PDU that IPv4 prefix, IPv6 prefix, router key, ASPR, and likely more RPKI data types in the future, such as there are many secure routing policy, spec language, and also so on and so forth. So we think that from the operator perspective view, so there are some optional solutions to help the operators select RPKI data synchronized to it. The first one, we may extend the SNUM to support filtering data by RPKI data type. The second one is to extend RTR to support the subscription the data type. So we think that the first one maybe looks simpler than the second one. The third one is suggested by the Job Snyder. That's the last meeting that we can losing the packets by the routers, but I think from perspective view, operator perspective view, that maybe still reduce some unnecessary transmission overhead. So we want to propose our discussion that does the network request all data types of RPK data, and whether to synchronize the RPK data that is not required by the network, and which solution is the best. And I think that for the operators that we want more simpler network and more simpler network operation. Thank you. Comments are welcome. Thank you.
Any comments or questions?
Hi, I'm Jeff Haas, Juniper Networks. So filtering the data can be potentially useful. A thing that we have seen in live deployment, especially at scale, is that when the RPKI data is being fed slowly, as an example, and BGP gets a little bit ahead of things, you can end up with a little bit of thrash inside of your tables or what the routers actually handle versus what policy and RPKI is in sync. So filtering is one way to maybe help with this. A second thing potentially for the working group to consider is maybe RPKI router either could be configuration at the back end, or it could be something passed via the protocol, can provide some hints that allow for prioritization of the things that are important.
Thank you.
Okay, thank you.
Hi, I'm Sheng Yue from China Mobile. Our topic is definition and problem statement for consistency in interdomain routing and forwarding. So next slide, please.
I've given you slide control.
Oh, thank you. Oh. So we first see what results in the inconsistency. Due to load balancing, anti-DDoS, etc., PBR or BGP flowback may configure to redirect traffic to a new next hop AS, which is different with the next hop AS determined by SPath in BGP update, and there is no control plan or routing protocol awareness. Take this picture for example. The expected AS path of AS1 is AS2, AS4. However, AS2 redirects traffic from S4 to S3. The expected AS path is AS1 to 4, while the actual path is AS1 to 3, 4. And the original AS cannot know that actual path. Another reason is ambiguous routing specification. Route aggregation will convert the ordered AI sequence to the unordered AI site. However, AI site does not represent the actual path of the BGP route. The original AS, maybe NAS, does not see the actual forwarding AS path from the BGP announcement. The inconsistency could lead to some security risks. Traffic black hole, there's no corresponding route for the next hop AS, resulting in a traffic black hole. The complete forwarding AS path is composed of multiple AS paths from different protocols, which may lead to unnecessary lengthening of AS path or loop. Malicious AS, the actual forwarding path is not visible to the original AS, which may cause its packets to pass through some ASs it does not expect. Non-optimal route AIs may prefer some AIs that may not be concluded in the actual path to select a non-optimal route. So the consistency in interdomain routing and forwarding means that inter-AS traffic is forwarded along the S path in the reverse direction. Yes, it's the S path attribute that records the S path number that is passed through. However, the actual forwarding S path is usually different with the S path in BGP update. So how to keep consistency of inter-domain routing and forwarding? We propose a solution with 2 steps. First, obtain deviation as path by looking up the as path in SIDROPS. Then the AS that generates the deviation as path is obliged to check and advertise it to other ASs. The consistency in interdomain routing and forwarding provide the ability of the original AS to plan its own forwarding AS path, and it can be used in internet visualization, interdomain source address validation, troubleshooting, and intent-based routing. So any questions or comments are welcome, and we will refine the solutions in the future. Thank you.
Okay, we're going to go to the next presentation then.
Hello, can you hear me?
Yes.
Okay, thank you. This draft is about profile for mapping origin authorizations. That is more. Next, please.
I gave you control of the slides.
Okay, thank you. This document proposes more. It is a new digital sign object API and is used for the verification address mapping announcement in multi-domain IPv6 only network. This draft was first established to SIDROPS before IETF 119. The current version is 4. So regarding to scenario, this document focuses on scenario of IPv6 only network in which the underlying network protocol is only IPv6 between only 2 P devices, but they can be dual stack at the edge. For IPv4 service delivery, IPv6 only network, IPv6 mapping prefix are configured as a PE to identify the location of each IPv4 network. So IPv6 mapping prefix is considered as mapping origin of given IPv4 address block. So in MPGP4 protocols, a new extension called ForMap6 is defined for announcing the mapping relation between IPv4 address block and IPv6 mapping prefix from egress PE to ingress PE. The problem statement, it is evident that the validity of transmitting IPv4 service data in IPv6 network lies on the authenticity of the mapping origin IPv4 address block. If a attacker maps IPv4 address block using a fake IPv6 mapping prefix, IPv4 service data will be routed through the attack control route and reach to its wrong egress PE, resulting in a situation of IPv4 address prefix hijacking. So this approach uses the RPKI architecture to verify the authenticity of the mapping origin of IPv4 address. It defines a new object called more. More is cryptographically some binding between IPv4 address block and its right IPv6 mapping prefix that is known to be declared in BGP announcement. With a more object, a legitimate holder of IPv4 address block, for example, ISP can authorize an IPv6 mapping prefix to map the IPv4 address block. So this is a e-content more, and the ancient one format of more is revised based on the comments of Russ Hosley and Job Standards. As an object of RPKI, since more is object of RPKI, before a reliant party use more to validate a mapping announcement, it must perform all the validation checks specified in RFC 6488, as well as additional more specific validation steps. So as mentioned that since this draft was submitted before IETF 119, comments contributions received, Job Standards give several improvements to more e-content. He also proposed as a definition of canonical ordering before prefix, which will enable IP routing protocol software to more easily verify the contents of e-content. Also proposed to replace RFC 6482 by its latest version in the reference section. And Russ Fosley gave a new version of Ansible module and one significant enhancement, which allow for several IPv6 prefix, and each of them is mapped to this IPv4 prefix. Jeff Hus and Dima joined as co-authors. So we are looking forward to receiving more comments and suggestions, and further refinement will be made to improve the whole document. And we authors would like to ask for working group adoption of this document. This is it. Thank you.
Okay, please, let's continue the discussion of this idea on the mail list. Thank you.
Oh, thank you.
Do we have the presenter?
Okay. Can you give me the control, please?
I did.
All right. Thank you very much. Good afternoon, everybody. So in this talk, I will discuss the FCPGP protocol specification. So we have been, since the past few IETF sessions, we have discussed the FCPGP. So in today's talk, we will basically recap on the basics, and then we will discuss some comments and suggestions since IETF 119, and we do some major changes from previous draft, and we will also report some implementation status. So for the time of sake, I will briefly introduce FCPGP. So it is a new BGP update validation scheme that adopts the per pathless validation scheme. In this case, each AS only cares about its immediate neighborhood, immediate pathlet in order to secure the entire path. So we collect a lot of the comments and suggestions from the group since IETF 119, including some of them are like the draft is somewhat light, lacking necessary materials, and demonstrating FCBGP is secure as BGP-SEC, and there are a bunch of others. So I will go through some major changes in this draft. So in the current draft, there are some key changes, including first of all, we removed data plane related content in this version, primarily focused on the control plane stuff. And then in section 1, we add the key differentiator of FCBGP, strengthening the partial deployment scenario. And in section 2, we also explicitly states the negotiating new capability is unnecessary. And in the section 5 and 4, we add additional protocol descriptions regarding the sending and receiving the BGP update messages. And we also add some other operational considerations and security considerations and so forth. I will go through some very high-level highlight changes. First of all, in the abstraction or in the first section, we define the key differentiator of FCBGP. So the primary differentiator is FCBGP and BGP-SEC offer the same level of security guarantees in case of full deployment, but FCBGP offers different level of security benefits in case of partial deployment. Primarily, FCBGP treats partial deployment as the first-class citizen. In the trait number 2, and we explicitly state that FCBGP relies on RPKI and also use the BGP keys to sign and verify forwarding commitments. And the change number 3 is we explicitly or give more practical descriptions about the sending and receiving process of how a BGP speaker should process FCBGP update message. And change number 4 is we explicitly state that the route selection policy. So we do not modify the priority of BGP route selection in FCBGP. And instead, we leave the route selection to the local policy. So the AS have their own local policy to basically process, to assign priorities for different passes. And change number 5 is the AS federation part, and we discuss how FCBGP works with the AS federation in case of a large AS have multiple small numbers. And we define some flags to be to handle this part of AS federation. Another big change is about the route server, and there are a bunch of cases where, like in IXP, there are some transparent route server which might not end its AS number into the AS pass. So in this case, we discussed 2 scenarios. In the first case is if the route server decides to insert its AS into the AS pass, it will basically, the RS will act like a typical FCBGP enabled AS. It will be processed at FCBGP as if it was a regular AS. But in the case if the RS does not insert AS into the AS pass, it will basically try to, the RS will populate the FCBGP segment into the FC list. And we specify some cases of, we specify how the RS should populate the FCBGP, FC segment in the FC list if it does not insert its AS into the AS pass. Oops. And the change number 7 is about inserting the AS number 0, and we discussed the security guarantees. We discussed the security issues. If there should be no AS0 in the AS pass attribute of the BGP update message. Therefore, AS0 should be used to populate the PASM field when no previous AS hops is in the AS pass. These are all the very high level, very highlighted changes we made over the draft. And for the implementation status, we have implement both software-based FCBGP prototype and hardware-based FCBGP prototype. In the software, we use the FRR, and in hardware, we are partner with the H3C company to develop FCBGP under CR1900 series. So there are some. These are some of the specifications over there. And next steps is we are looking forward to the working group adoption, and we also welcome new additional comments for this FCBGP draft.
Okay, would you please make that request on the mail list?
Okay, thank you.
So we are down to just a few minutes left. Please keep the presentation to the highlights.
Okay, thank you. Hi, everyone. I'm Qi from Zhongwen's laboratory, and I'm excited to share our new draft here and hope to get some feedback from the community. Our draft propose a SIGN MOS group SMG, which is a preliminary solution to protect the legitimate MOS route in the network as a complement to RPKI. Let's start with an overview of the problem. According to the RFC 1930, a prefix should typically have a single ASs as its origin. However, KDAS analysis on BGP routing data reveals that the MOS has become a common phenomenon. For example, some commonly adopt MOS to mitigate DOS or DDoS attack, and some service providers also announce the same prefix in multiple ASs to achieve traffic engineering goals and ensure a high-speed and reliable data service. Although this practical design significantly improves the network availability, it is difficult for networks to distinguish between the prefix hijacking and legitimate MOS conflict, as they are often display similar characteristics. To identify the possible hijacking among numerous MOS conflicts, the network managers might use current root origin registries such as RPKI. However, we analyzed the MOS route in the past years, and we found that only about 21% of the conflicts are validated as legitimate. In fact, over 700 conflicts per day were classified as invalid, which is nearly 10 to 90 times higher than the result from the current monitoring system. It's clear that these conflicts are not all the routing security incidents. Most of them are just normal traffic, but they are highly susceptible to being dropped by the ROA system. One of the reasons is that the ROA only indicates the authority by the prefix holder for the ASs to advise this to advertise this prefix. However, in many scenarios, the authorized AS also collaborate with other ASs within their organization for the traffic engineering goals. So in this example, the VoIP customer just outsourced the prefix to ASA and issued an ROA. However, the ASA may collaborate with other ASs in the same organization to advertise this prefix. But from the perspective of other network, only routes from ASA are valid. The legitimate traffic from the collaborating ASs will be flagged as malicious by ROV. We have observed this happening in the real-world internet routing, and here we show two concrete examples. And to mitigate this, this issue, we propose a SIGN MOS group, SMG, to assert that a group of ASs intended to collaborate announce an IP prefix. And the SMG object includes two main fields, and an IP prefix and an AS list. The SMG should be signed by all the listed AS, which confirm that all these ASs have agreed to announce this prefix together, ensuring the announcement is legitimate, accurate, and mutually authenticated. And we also highly recommended that at least one of these ASs should be authorized to announce this prefix through ROA. And this is an example of a DER encoded SMG object, and the detailed description could say or draft. And here we will briefly describe the protocol for issuing and validating SMG based on the aggregate signature. In the issuing protocol, each AS in the AS list should sign the SMG group, SMG object by its private key, and the authorized AS should verify and aggregate all the individual signature into a global signature and finally attach to the object. And to validate it, the relying party will perform 3 steps. First, check the format. Second, signature verification, where the RP aggregates all the public key into a global key and to verify the global signature. And third, a consistent check, which means the RP checks that there is a corresponding ROA, which has the same prefix and AS list is listed in the object. And SMG is designed to complement the ROA system, and it could integrate with ROV while operating independently, but providing additional benefits. And we just allowing the space of all possible combinations of ROV and SMG verification here. At last, we implement a prototype of assembly in Golang and evaluate the performance of each operation. And we can say from the result that the entire procedure of issuing an SMG, including 3 ASs, only need about 4 milliseconds, and the RP only needs 1 millisecond overhead to validate it. In conclusion, we propose a sign MOS group SMG to enable multiple ASs to announce an IP prefix clarity and security. And it could support the scenarios such as the business collaborations, traffic engineering, and DDoS mitigation. For more details, please read our draft. Thank you very much. That's all.
Okay, we're out of time. We have one last presentation. I'm just going to ask the speaker to do a few highlights. We certainly don't have time for your whole slide deck.
Okay, thank you. I cannot control the slides now.
I did give you control.
Thank you. So I will quickly introduce the highlights of the updated version of ByteConcept. ByteConcept aims to enhance the SAV robustness by using a block list generated by BGP updates, ROAS, and ASPARs related to the provider code. It can help avoid improper block and can work together with existing SAV solutions that generate a love list. And we have revised this document according to comments received from IETF 119 and on the mailing list. And here shows the comments received from Ben Madison, Keith Ram, and Nangang. We revised this document. Specifically, we add a new section to introduce the goals and a new section to introduce existing allow list-based SAV and describe how to deal with the overlap between provider code and custom code, and provide a summary of recommendations. ByteConcept has 2 goals. The first goal is avoiding improper block, and the second goal is maintaining directionality. The block list can perform better in achieving the first goal because it helps avoid improper block, and the allow list performs better in achieving the second goal because the block list can have more improper admits than the allow list. And here shows an example. In this example, we show prefixes in allow list and block list. In this figure, we consider SAV on AS1 to AS2 interface. If we use an allow list, it must contain all prefixes belonging to the customer core of AS2. So if a prefix is limited propagated in the customer core, the allow list may miss this prefix, leading to improper block. And if we use a block list, it should contain as many prefixes belonging to the provider core of AS1 as possible, and it must remove prefixes that also belong to the customer core, such as the prefix P2. So we provide the recommendations that network operators can use either an allow list or a block list on different interfaces facing a custom AS or a lateral peer AS. Specifically, if the network operator can ensure the allow list cover all prefixes in the customer core, it's recommended to use an allow list. For example, when the customer core is relatively small or ASs in the customer core have registered as sparse. But if not, it's more recommended to use a block list by default to avoid potential improper block. For example, when the customer core is large or some ASs in the customer core haven't registered as sparse. So in summary, ByteConcept provides an additional option for network operators to deploy SAV on interfaces facing a custom AS or a peer AS by generating a block list. It can help avoid improper block and still maintain core-level directionality. And network operators can flexibly choose to use an allow list or a block list according to their needs and the actual situation. We thank these people for their thoughtful comments. So in the next step, collaboration is welcome, and we'd love to request working group adoption for this document. And comments, questions are welcome on the mailing list. Thank you.
Thank you. Please send that request for adoption to the mail list. So we're over time. Obviously, we need a longer slot next meeting. And thank you very much for staying late.
All right. So